think I'll just take a fine.
No USB in.
No, it's okay. I have an adapter, but I don't.
Okay.
It's okay. Thank you. Testing. Testing. 1, 2, 3. Am I audible in the Zoom? Bisa kedengaran?
Yeah. Okay.
Okay, so good day to everyone. I'm Alicia from i3L's International Office. Hope you're all doing well today. Welcome to our Power Talk session for today. For those who are here online, thank you for joining us, and welcome to our newcomers as well. The Power Talk will be on the topic of breathing in focus, exploring indoor and outdoor PM 2.5 levels, and personal exposures, presented by Dr. Marina Vance, U.S. Fulbright Scholar and Associate Professor in Mechanical Engineering and Environmental Engineering at the University of Colorado Boulder. Thank you so much for coming today, Dr. Marina Vance and our friends from Aminef. Now, aside from being your moderator for the day, as the head of international office, I will also be representing i3L. And on behalf of i3L, I would like to thank our friends from the America-Indonesia Exchange Foundation, or AMINEF, for making today's Power Talk seminar possible. We extend our deepest gratitude for your availability today in expanding the knowledge of our students with Dr. Vance and sharing her research in a study she leads at IPB University. Myself and our attendees for today, look forward to learn more about your research in measuring how much PM 2.5 are people exposed to indoors and outdoors, and in which I would also like to add to our attendees here today. Low-cost sensors that provide quick results are used in the research, so we can see how much air pollution people breathe in during their everyday lives. And once again, I would like to thank you for being here today. And I now would like to welcome the representative of AMINEF, Ms. Astrid Lim, Senior Program Officer, American Program at the America-Indonesia Exchange Foundation. Ms. Lim, the floor is yours.
Thank you, Ms. Alicia. Good afternoon, everyone. Thank you for joining us in this event, those who are in room with us or online from your respective houses. And thank you for i3L for your availability and willingness to host this presentation from one of our Fulbright scholar, Dr. Marina Vance. So my name is Astrid Lim. I'm from a representative from American Indonesian Exchange Foundation, or AMINEF. So we are the Fulbright Commission in Indonesia, who administers the Fulbright program, both for Indonesians going to the US for studying under the Fulbright Scholarship, and for Americans coming to Indonesia with Fulbright funding to do research or teach at universities and schools around the country. If you are interested in applying for one of our programs, please, or for i3L to invite Americans expert to your institution, please feel free to read the materials we bring today, or if you are at home, go to our website and reach out to us with any questions if you have any. So for today, as Ms. Alicia mentioned, we will listen to Dr. Vance. She is one of our most prominent Fulbright scholars this year who conducted research with her local partners at IPB Bogor. Her research topic is still very important and should I say very relevant with what we, especially those who live in Jakarta, experience in our daily lives. Sometimes we forget that having clean air free of pollution is a basic human rights because we are getting too used with the pollutions we experience every day, as Dr. Fan may testify later for your 9 months living in Bogor. So I hope Dr. Francis' talk today can give us all deeper knowledge about the issue and more hope for the future cleaner Jakarta and Indonesia in general. So I wish you all a great session and fruitful discussions afterward. Thank you.
Thank you so much for your welcoming speech, Ms. Lim. We're glad to have you and your team here. And we now proceed to our Power Talk seminar today titled Breathing in Focus, Exploring Indoor and Outdoor PM 2.5 Levels and Personal Exposures, brought to you by Dr. Marina Vance. Now there's going to be an attendance and evaluation form that you will need to submit. So do please scan the barcode for that attendance. which will be provided at the end of the session. Now, without further ado, I give you Dr. Marina Vance. Thank you for your presentation. The floor is yours. Oh, was it working already? Oh, I stopped it. We'll do it again. Is it working? Yeah, okay. I have a lot of things open. All right. Hello, everyone. Thank you to those joining us online, and thank you to those joining us in person. I really appreciate all of your attention to my talk today on a topic that I personally consider very important. So the title of my talk is Measuring Personal Exposure to Fine Particulate Matter Using Low-Cost Sensors. My name is Marina Vance. I go by Nina. I'm an associate professor of mechanical engineering and environmental engineering at University of Colorado Boulder. And for the past 5 months, I've been living here in Indonesia doing research in air quality. So I'll start talking a little bit about myself. So I'm originally actually from Florianopolis. It's an island in southern Brazil. And then I moved to the United States to get my PhD and became a faculty member at University of Colorado. So we are spending this year in Indonesia, and then we'll return to University of Colorado as a family. The University of Colorado, where I work, is a public research institution. It's what's considered a large university campus in the United States with over 30,000 students and 1,200 faculty, tenured and tenure track faculty. We have over 230 degrees and offered in many disciplines, both undergraduate, master's, and PhD programs. And the Boulder area where I live and where the campus is, this is the same location in winter and in summertime. Looks very different, but I consider them equally beautiful. This whole area is well known for a lot of air quality research. So not only do we have the university where I work, but also another university, CSU, just 1 hour away. And then we have 4 national institutes from the United States in this area: NIST, NCAR, NOAA, and NREL. I won't bother giving you the full names, but they all have some area with a lot lesser or larger focus in air quality. So it's a very nice place to work and study air pollution. My research group specifically performs experimental research on the physical properties of aerosols or particulate matter. And I'll explain a little more about particulate matter in a minute. So as I mentioned, over the past 9 months, I've been living in Bogor in West Java. And the title of my project there, funded by the Fulbright program, is Assessment of Particulate Matter Concentrations in Java using low-cost and fixed and mobile sensors, and looking at implications for local air quality monitoring. So at this point, I'd like to give my deep thanks to the researchers at IPB University in Bogor for hosting me over the past 9 months. They've been wonderful people to work with. So as we get started about air quality, I like to explain a little bit more why I feel so passionate about it. And I like to use something called the survival rule of 3 to talk about it. I don't know if you've ever heard about it. Have you ever heard of the survival rule of 3? It's something that's on Wikipedia, and it states that people can survive about 3 weeks without any food, about 3 days without any water, about 3 hours in a very harsh environment, so very, very hot or very, very cold. And can you guess what's coming next? Air. How long do you think you can survive without air? It's not gonna be a 3, it's not 3 seconds, it's not 3 hours, it's 3 minutes. That's right. 3 minutes without air until our brain starts losing oxygen, and then, there's no turning back. So I would argue that another important reason to care about air quality and the air we breathe is because it's more difficult to control on an individual level. What does this mean? It means that if you go to the tap and you open the water tap in your house, and the water comes out and it's all brown and it smells really bad,
You put that in a cup, would you drink that water? Of course not, right? You have that choice to put that in your body or not. Now, if you walk outside and the air is really polluted, you have some options to, reduce your exposure, but for the most part, you cannot choose to not breathe, right? Just like you can choose to not drink or not eat something, you cannot really choose where to breathe, where or what you're breathing. So that's why I care about air quality. Specifically within air pollutants, I care a lot about particulate matter. Particulate matter are gases or liquids suspended in air, and it's all around us, right? From regional sources to local sources. Some are indoors, some are outdoors. Some is being generated right now in Indonesia, right? That's the wrong volcano there. It should have replaced by an Indonesian volcano. And some everyday sources of particulate matter. Oh, let me make that. Well, I don't think I can make that bar go away too easily. Let's see. I think if I try to do that, I can't do it. Should I try? I should try. Oh, there it is. Yay. Okay. Some everyday sources of air pollution. Now, can I go back to? Okay. Some everyday sources of aerosols or particulate matter include combustion, and that's all the pictures on the top row. Some are outdoors, some are indoors. And then there's some more novel or maybe less studied sources, and those are all at the bottom here. That includes cooking, some office products, some personal care products, and even ourselves, right? We are a source of respiratory aerosol, as became abundantly clear during the pandemic. So within all those aerosols, the most widely studied is fine particulate matter, also called PM2.5. So if you remember anything from today's talk, is what is PM2.5? It's the world's leading environmental risk factor. It's associated with uncertainty in climate models. It's responsible for millions of deaths worldwide. It shortens people's lives all around the world. And that's through cardiovascular disease, respiratory issues. It can affect our brain. The particles have been shown to transport through your body and get to the brain and affect mental health and aging and things like that. And here it is, PM2.5, that tiny little particle. That huge picture right there is human hair, one strand of human hair for scale. And this is what PM2.5 looks like. So very, very small. PM10, of course, aerosol is much bigger, 4 times bigger. And here's an ultrafine particle, which would be 100 nanometers. So just to add some context, I took a screenshot on my phone 5 minutes ago before starting the talk, and I just put it over there from iqair.com. They list the air quality index around the world. And unfortunately, right where we are right now in Jakarta, it's number 2 in the world, right? With a US air quality index of 169. And that's because the concentration of these particles that I just showed you, PM2.5, is 77.6 micrograms per cubic meter, which is a very high number right now, second in the world from the cities that they're monitoring, of course. So beyond understanding what the air quality looks like outside, I think I'm very passionate about trying to understand them in indoor environments as well. And the reason for that is that we've performed this survey and we have the data, but we all know this. We spend the majority of our time indoors. Maybe the air pollution is all outside, but our lungs are actually inside. So we need to understand what happens to these particles and all the other air pollutants when they travel from outdoors to where we actually are. So this survey from the early 2000s, late 90s, was done in the United States, and it showed that people spent 87% of their time indoors. There's been a different survey done in South Korea, and not too many all over the world, but it's fair to assume that people in many areas spend the majority of their time indoors. And amongst that, about 70% of the time was actually in a residence, in their own homes or somebody else's home. So to me, this is one of the reasons I feel passionate about understanding the air quality inside our own homes, because that's where you actually spend the majority of your time on average. Additionally, it's important to understand indoor environments because our buildings are becoming more and more airtight. So in the past, homes used to be a lot more drafty and open to the outdoor air. So outdoor air pollution was the same as indoor air pollution because the air is coming into the home. But nowadays, homes are becoming more tight. That lowers energy consumption. It's great to operate an air conditioning system and keeping the temperature right. That also is nice because it lowers the penetration of outdoor air pollution. So outdoor pollution is not coming in as much as it used to, right? But on the other hand, it might increase your exposure to indoor air pollutants. So if you're cooking or you have candles or incense or other air pollutants that are being released inside your home, they're not really going out because you don't have air circulation from outside. I'll also talk, most importantly on this talk, about personal monitoring. Personal monitoring is when you take an air quality monitor and you carry it around with you. So I have the monitor that I use for this project right here. So it's very small, it's battery operated. That means that I can attach to myself. And as I walk around, it comes with me. That means that it's measuring everything that I'm inhaling. So it's not in one steady location, and then I have to make some math to try to adjust where I was in relation to the measurement. No, I don't need to do any adjustments. It's already measuring what I'm inhaling, right? Because it's portable. I also measured CO2, and I'll show another one later. This one is fixed. It doesn't go, it's not battery operated, can't be carried. So it's important to measure that because there's a concept called exposure. Exposure, as you can see in the slide, is concentration times time. So we're exposed to a very high level of PM2.5, but maybe only for a few minutes. So by multiplying by the actual amount of time that you spent observing or experiencing a certain concentration, you can tell the complete picture. So it can add detail to things like spatial data. So here's a map of Indonesia, and it shows this really big brown cloud of poor air quality around Jakarta, and Bogor, as you can see, is engulfed in the same cloud. So if we zoom into Bogor, from the same website I showed you before, the iqair.com, all of Bogor, downtown Bogor, is showing as brown. And you can see in the legend down there, it says sensitive for, what is it? Unhealthy for sensitive groups. And it says that the whole area is brown because there's no granularity in the data here. There's no special detail, right? But in the reality, we know that it's a little bit different, right? We know that even within this 1 square kilometer area there that I marked off, that one little square, we have several different environments, right? Somebody might be sitting at the Bogor Botanical Gardens, the beautiful Kebun Raya. Somebody sitting there on the grass, they might be experiencing a different air quality level than somebody who is in the same area, but immersed into traffic, right? They're in the back of a motorcycle and they're just inhaling the exhaust from the other cars. In the same area, somebody might be inside a classroom at the IPB downtown campus in their Baranancian campus. Or they might be right next door inside a fancy mall. All of these people might be experiencing very different air quality and PM2.5 levels, even though the map is telling us that we're all, in the same situation. We know that's not the same. So there's been studies done in the past about this. The data I'm showing here is from several studies, 13 countries that were all organized by this study over here, published a couple of years ago. And they found that basically for every increase in outdoor air pollution, the personal measurement from somebody increased by 0.56. So that means that what was measured outside, on average, what the person experienced was a little bit lower because they're spending the majority of their time indoors. It makes sense. They found high variability between countries and season and urban versus rural area and all of these things that I'm trying to show, right? And one great example is my daughter over there. So you take Maya inside our home, the picture in the middle, she might be experiencing a very different air quality level compared to just walking down the street in the evening where we could smell that there was some trash being burnt. Or if we go down the street a little further to a square where people are doing a lot of cooking, right, on the weekends. So we're in the same neighborhood, but we might be experiencing very different levels of air pollution. So that takes us to the project. So the science question was, do personal PM2.5 exposures in Bogor differ from what was measured just in one spot in a fixed monitoring location? And if so, by how much? And then we did a lot of quality assurance steps that I'll go over in a bit. So our study area is Bogor. I'm going to show you data from car rides, motorcycle rides, and they're all shown in that map. So covering good coverage in the area. And then the first thing that we have to do, and the first recommendation we have for any study that's trying to use this little guy and compare the data from this $250 monitor from, with an research grade instrument that may cost hundreds of thousands of dollars. The quality of the data cannot be the same, right? It will not be the same. So if you want to use these data correctly, you really need to co-locate it with a good quality instrument and then perform some corrections, calibrations, see if the data are any good. So what we did was we collaborated with IPB University, and then they collaborate with NICE, the National Institute for Environmental Sciences in Japan, who runs this very nice air quality monitoring station on top of a tower, on top of a building, 20 meters high. So they have these measurements, and we know we can trust these are good quality PM2.5 measurements. And then we run our little instruments at the same time as that one, and then here are the data. So the Purple Air, which is a very popular air quality monitor, is this guy, overcounted by a lot. So that's the purple line. The name's Purple Air. We're painting it in purple. Much higher than the tower measurements, right? And this is well known. The literature knows that this guy likes to overcount particles for a variety of reasons. The Purple Air, the Atmotube, this guy that I'm actually using for the project, is in orange, and it's agreeing very well with the air quality monitoring station. If you look at the data plotted side by side, they're very close to the red 1-to-1 line. If we apply a small correction of 0.89, we get our data to agree pretty well. So this is great. That means we can use this for this study. So what we did was walk around and go by our everyday activities for about 8 months. And we're logging the particle concentrations, a bunch of other things, and also CO2. And these are some results. So I'll show one day as an example. So September 18, just a random day. Just show you that a few patterns start emerging as you're looking through the data. So in gray is time spent at home. Concentrations are not varying by a whole lot. The yellow is showing periods in a car. So what happens when you enter a car and you close all the windows, the CO2 that people are exhaling is accumulating inside the car. And it rose incredibly to a point where you can't even trust those measurements from the CO2 monitor anymore, 4,000 ppm in the afternoon. And then the PM2.5 concentrations actually dropped significantly because the car is sort of shielding, protecting you, filtering out the particles from outdoors, here and here. And then when you're in the office, this particular person in the office for that particular day, concentrations don't change very much because what's happening is in the office, there are no sources. There's no combustion, there's nobody cooking in there. So the particle concentrations don't change very much. They're just coming from outside and getting filtered out a little bit. And then whenever that person went for a walk, CO2 levels dropped, concentrations of PM increased a little bit. And then whenever they went to a restaurant or the mall, there's cooking happening inside. So PM concentrations shoot up because of the indoor concentrations of PM. So those particles are not coming from outside. They're coming from inside the mall. And then what I'm showing here now is what the tower was seeing at the same time. So you have similar pattern throughout the day, but much less detail, much less variability in the data because the tower data are collected every 3 hours. All right, but this is just one day, it's just an example. Now let's actually get everything together and try to understand our data. And that's when the analysis can get a little bit more powerful, right? Looking at one day at a time is not very beneficial. So here's all the data that were collected throughout the many months. It showed an average PM2.5 concentration, 24-hour average of 25 micrograms per cubic meter. The WHO standard is now 15 for a 24-hour average. They say you can exceed that 3 to 4 days a year. So we're well above that, right? Because the mean is above it. That's the red line on the plot. And then the purple line is the Indonesia 24-hour air quality standard, which is 55. That's for a 24-hour average. So we cannot compare the little dots. Those are instantaneous measurements, but we need to compare the black line to it. And the black line did go above it for a few days in November. When you compare the tower with the personal measurements, what's interesting here is that what the people in this study, there were 3 people wearing the monitor, what the people experienced was very, very similar to what the tower, the fixed location, was experiencing, which was surprising to me because I expected this ratio to be much lower. As people are indoors, they're a little bit more protective, but it wasn't the case. So the mean was about 1.06. So very similar. But let's look what happens if we separate our data based on where people actually are and what they're doing. So we're looking at transport modes here. These data are showing the car, motorcycle, then walk, and then just for fun, let's look what happens inside an airplane. Nobody's taking an airplane to go to work, but I figured it would provide interesting context. So what we see here is an average of 16 micrograms per cubic meter for the car data. And for motorcycle, it was more than twice, it was 33, just about twice. So as expected, riding in a car is more protective than riding in a motorcycle. Now, if we compare to the tower measurements, that's this plot over here, the ratio for car to tower was 0.7. That means that riding in the car was 30% cleaner air than what's happening outside. Riding a motorcycle, on the other hand, was 1.4. So being immersed into the traffic, you're experiencing worse air pollution than what the tower is measuring, which is representative of the whole city. Going for a walk was just about 1, and that's what we were hoping for. That makes sense. You're walking around, the tower is representing that exact situation. And then an airplane, very, very low, right? The average was about 2 micrograms per cubic meter. So that happens because most airplanes have HEPA filters. So they're filtering the cabin air as you're riding in the airplane. So the air quality in the airplane is very, very good in terms of particles. There can be ozone and other things. I won't get into it. But in terms of particles, air quality in an airplane should be super good. Now let's talk about different indoor environments. So here we separated our data on home, office, mall, gym, cafe, and airport. A few different homes, a variety of offices, number of malls. So there's variety here in the data. The gym was just one, but everything else. And the airport is the Jakarta airport, just one airport. So what you see here was concentrations were very high at the airport, but that's also located in Jakarta, it's not in Bogor. So, you know, you got to take that into consideration. But it's well known that the jet fuel emissions contribute to poor quality as well. Beyond that, what we see if we look at all these ratios between these indoor environments and the tower measurements is that the office was the only environment that had a ratio less than 1. So that means the office was the only one that was witnessing lower air quality, better air quality, lower concentrations than outdoors, than the city in general. The home was worse, the mall was much worse, the gym and the cafe, they were all higher, especially the mall and the cafe, because cooking is taking place in those environments. So particle concentrations are expected to be higher. So this is looking at these individual environments. And then if you look, go back to the previous slide, you might look at these data and be like, okay, that means that I need to ride my car. I need to not be on a motorcycle. Well, that's not very realistic, right? Especially in a place like Jakarta or the metro area. If everybody gets in a car, we're going to make the problem worse, right? So that's not helpful. So instead, let's see if this actually makes a difference. There's a way we can do that, and that's by looking at a scenario. So let's investigate the number of hours. Remember, exposure is concentration times time. So just looking at the concentration is not enough. We need to look at the whole picture. So among 24 hours in the day, let's assume that somebody spent 12 to 13 hours at home, 1 to 1.5 hours in transport, 8 hours in the office. And let's say it was a great day. They went to the gym. They spent an hour at the gym and an hour at the mall having lunch and a snack or whatever. So this is maybe a representative day, maybe not, but it's a point of comparison. So let's look at 2 scenarios. If they're taking a motorcycle ride, the ride will be shorter, right? Because they're going to get to that place a little bit faster. So that ride is a little bit shorter. So let's add that to the home time. So that's why the blue bar for home is a little higher. That's because this person's spending a little bit more time at home because they're saving time from their commute. They're not going to spend that extra time in the office. They usually spend that time, I would expect, at home. The other bars are unchanged. So using this analysis, the total difference, the total exposure by spending your rides in a car was 596 micrograms per cubic meter times 20 per 24 hours in a day. For motorcycle, it was just a little bit higher, 618 micrograms per cubic meter. That's only a 4% difference. So although a motorcycle had twice the concentration of particle PM2.5 compared to the car, the total daily exposure, if you consider the whole day, you do a more holistic analysis, the difference is only 4%. And the time, and this is because the time spent at home corresponded to 60% of the exposure for this person, because the majority of their time they're spending at home. And in this particular scenario, one of the homes, I think both homes actually, that we studied had very high concentrations of PM overnight. And those particles were getting inside and they were leading to the majority of the exposure. So changing the transport mode will make a very small difference. So if you're going to think about where to tackle the air quality and limit this person's exposure, you don't go here, right? You don't go to transport the smallest bar in your plot, you go here and you try to limit that person's exposure at home. Of course, we can't ignore short-term exposure. So literature shows, studies show that exposures as low as 1 hour to 1 day can lead to negative health effects. So I'm not saying it's okay to be in the back of a motorcycle inhaling hundreds of micrograms per cubic meter. There are studies showing that even those short-term exposures to very, very high concentrations can have negative health effects as well. So there's some strategies we can use to protect ourselves from outdoor PM2.5. So that's the outdoor air pollution. This is a particularly beautiful sunset in our home in Bogor. And that sunset is that beautiful because there are many particles in the air scattering the light. It's unfortunate, but it's true. So the more obvious advice is to avoid outdoor activities on high pollution days. So be outside because you have to be outside, but don't choose to go for a run on a day that's extremely polluted, because you're going to be bringing in more and more air pollutants and you're putting a bigger stress on your cardiovascular system, because particles have been shown to move to the cardiovascular system, your heart, right? Another way, of course, is to wear a mask if you're exposed to traffic exhaust. KN95 masks work really well, particularly the KN95 N95. But the key thing is that they have to seal very well. If you can feel that there's air coming in and out whenever you inhale, usually at the bottom or at the top, then they're not working well at all. They have to seal. Strategies that we can use to protect ourselves from the particles indoors are varied. If the source is coming from the home, if you're thinking about cooking, if you have a lot of incense burn, well, you can eliminate the source. Don't burn things inside the home. But if you're doing that, you can remove or control at the source. You can have an exhaust hood that sucks the air out and put it outside. That's one way. You can ventilate or dilute, which is something that in the Jakarta context doesn't make much sense. So what you do is if you're going to be cooking and you're emitting a lot of air pollutants, or you're using harsh cleaners and you're putting in a lot of chemicals in your home, you want to open the window, you want to ventilate that out. But then you have to look at the outdoor air pollution, right? If it's bad, then it won't work. Finally, another way is to treat the air, filter out those particles. So a portable cleaner, these have become super popular in the past 5-10 years. They're available in many places, in many big cities especially. I would recommend a nice quality filter. They're usually called HEPA, HEPA, high efficiency particle air filter. Those work pretty well. I don't personally recommend any chemical treatment of the air, corona discharge, electrostatic precipitators, and things like that. Particle filter is sufficient. It works very well for particles. Oops, this slide does not belong there. So that's what I had to show you today. In summary, we showed that some low-cost sensors required significant correction, like these guys, but some responded really well with minor correction. So I would still recommend doing a correction if you're going to use this for any scientific purpose. If you want to actually publish your data, don't just publish what you see here. You have to make sure that this is working well before you use the data. But for a consumer application, the performance is really adequate because it shows people when the air quality level is bad and when you should do something about it, right? So for consumers who are not using it for scientific purposes, you do not need to do calibration, co-location. You can just use it. It's fine. In terms of personal exposures, we found that they vary significantly with transport mode and with indoor environment. But the total transport mode, the total exposure really was mostly from being at home and being in the office, which is where people spend the majority of their time. So if you're gonna do something to reduce your exposure to particles, my recommendation is to think about the environment where you spend most of your time. So although the PM concentrations can vary greatly from location to location and transport mode, the exposure is largely dictated by where you spend most of your time. If my home were, well, not just my home, there are multiple homes, but I keep forgetting. If the home in this study were well sealed from outdoor air and had a filter, I would be telling a completely different story, right? If that exposure were very low, then you can tackle others. But in this particular case, the exposure at home was where the attention should be placed. All right, with that, I'd like to acknowledge a bunch of people, particularly the Fulbright Scholar Program that enabled me to have this amazing opportunity to live in Indonesia for 9 months, and Aminef for doing a great job managing the program and organizing today's talk, as well as i3L. Thank you so much for having me here. IPB University, who have been my wonderful hosts for the past several months, and then the National Institute for Environmental Sciences in Japan, who's allowing me to use their data on this study. Thank you.
Okay, thank you so much for that insightful seminar and discussion. So we now proceed to our Q&A segment for the day. And we can start with 3 questions from the audience that are live and 3 more from the Zoom, and we'll proceed from there. The ones from live right now, I'll take 3 questions. Yes? Is there a...
Hi, Dr. Marina Fence. Thank you very much for your explanation. So, yeah, I really interested with your presentation. Now, I have one question. So before I raise the question, I just want to give a little bit background for myself. So, my name is Anand. So I'm working, or I'm a lecturer in a food science and technology department. Now, since you are mostly talking about the inhalation, I mean the PM2.5 matters, which is inhalation. I'm just wondering, I don't know whether it's you know it or not, but what if, let's say, because this type of matters are actually also exposing the animals, let's say chicken in this case, and then the chicken meat might be you know, contaminated with this PM 2.5 matters, right? And what if this PM 2.5 matters we are exposed to through, you know, consumption instead of inhalation? Would that still give the same toxicological effect, or is there any kind of different effects, or, you know? Now I'm just curious about it. Thank you.
Thank you for your question. That's a great question. I didn't quite understand the part about animal studies because I'm not talking about that at all. But in food science, I understand that you're curious about what is the difference in health effect between inhalation exposure and digestion exposure, right? Ingestion as an exposure route. And that's really important. So the field of exposure science has several exposure routes that need to be considered. Inhalation is just one of them. Ingestion is another. Dermal contact, touching, ocular exposure. These are all different fields that are studied independently. So from respiratory versus ingestion, I can tell you that it ends up in very different parts of our body, and the health effects are completely different. So just like I can drink lots and lots of water and it's going to be great for me, if I inhale a little bit of water, it's very, very bad for me, even though water is not toxic, right? So same thing happens to your lungs. The way the particles are toxic is because they line the alveolar region and they create what's called oxidative stress. So they damage the cell lining of the lung. When these same particles end up in your stomach, the stomach acid is just going to digest them like it would food. So the one exemption to that rule that I would mention is heavy metals. They're bad inhaled and they're bad ingested. But the amount that you need to ingest to be toxic is a lot more than by inhalation. Thanks for your question. I hope that answered it.
Okay, thank you for the first question. Second question from the audience.
Thank you for the interesting presentation. My question is, does planting lots of trees help reduce the particulate matter? Yeah, that's it. Thank you.
Thank you. That's a great question. So if planting trees and bushes and things can help with air pollution. Oh, that question is complex. So outdoors, trees and heavy arbory has been shown to act as a filter for particles to some extent with varying degrees of success. So the smaller the leaves, the more wavy the pattern of the air, so the better they work as a filter. But just planting some trees in a city without understanding how the air gets transported might do something, might do nothing. There's studies that show that it worked great and some that it didn't work at all. Because if the air goes like this, then it didn't work. Now, I need to mention something that a lot of people believe in, and there's several studies showing it's not the case, is that having a plant inside your home will improve the air quality because the plants are known to absorb air pollutants and they emit oxygen. But the reality is that they emit oxygen during the day when they're performing photosynthesis. During the nighttime, they're emitting CO2. So it's just gonna, it's not gonna work out great. And the whole thing about the plants absorbing air pollutants, they do that, but you would need an entire forest inside your house for them to actually make a difference. And then at that level, the soil is going to be producing probably mold and other problems. So the outcome turns out being negative. So don't believe a plant inside your home. I have plants inside my home. I love them. They're great for mental health, but they're not going to treat the indoor air. Yeah, unfortunately.
All right, thank you for the second question. Third question.
Right. Thank you for the presentation. I'm just wondering, the data that you have presented there, did it also come from like during rainy season as well as the non-rainy season? I noticed that's one from November. I believe that's pretty high, although that's still, I mean, Bogor, we all know that Bogor has a really high rainy, in terms of the amount of rain falls in Bogor. I mean, that makes me wonder, as well as if the environment is kind of like, you say if it's being sealed, because like most houses, it's like, closed environment with only AC. And then I'm just wondering, is there any like, difference if you are using AC on or just like using the normal fan kind of thing? So.
Great questions. Thank you so much. So first about rainy season versus dry season, and second about air conditioning. So we did collect data from rainy season and dry season. I'm doing this whole other side analysis on the effects of seasonality. I haven't done that yet, so that's why I'm not presenting today. It was difficult to find. We've seen that other colleagues at IPB have shown that there is an annual pattern. Dry season tends to be worse and rainy season a little bit better. It's not just the rain helping, it's also there's crop burning and more burning in general, and maybe activities are also different, dry season versus rainy season. So it's not all the rain, there are other things at play. Hoping to do a little bit of that analysis later, but it's really difficult to get like a really good answer because as you know, Bogor is Kota Hujan, so it rains year round. It rains more in the rainy season, but it's dry season is not dry. So it's very difficult to actually get dry data. The variability in the data is not as big as you would want for this kind of analysis. And then about air conditioning, yes. If you have a home that's very well sealed and has an air conditioning system, technically you should be experiencing lower particulate matter concentrations indoors compared to outdoors. I have a site analysis that I'll try to do that, showing a room in the house that was hopefully well sealed. But you'd be surprised how sneaky these particles are. If you have a minor draft, they're coming in. And if the minor draft is for hours and hours, then the concentrations will end up equalizing at some point. Thank you.
Thank you. And now we'll take questions from the Zoom. Ms. L, if you can moderate, are there any questions from the Zoom so far? Not yet. From my end, I'd like to have a follow-up question from Mr. Mario's question, which is, so does temperature actually affect how these PM2.5 operate actually?
That's a great question. And the answer is not really.
Not really?
Not really. What happens is maybe with the difference in season or temperature, our activities that generate those particles might change,
Oh, okay.
right? And there might be differences between extreme low Siberia, Alaska, and extreme hot. But within the context of Indonesia, that won't play a role because the temperature doesn't change that much.
True, true. Yeah. Okay, thank you. Further questions?
I'm talking about like the experiment was conducted in Bogor. I'm just wondering, is it like the particulate matters, they all come like being produced by Bogor area itself, or is there any, because of the wind blow from Jakarta or from somewhere else, then it kind of like, contributes to the area as well?
Yeah, definitely. So the wind patterns and the regional transport of these particles, PM2.5, does happen, and they can come from quite far away. There are colleagues at IPB that are using models to try to understand where the air pollution comes from in Bogor. A lot of it comes from the Bogor area itself, and some of it can come from Jakarta, for sure. And to give you an extreme example is that dust from the Sahara Desert can be seen all the way in the United States, in Canada. Yeah, they can transport through stratospheric transport all the way. So yeah, particulate matter can travel far, far, far away. For Bogor specifically, that requires a more intense analysis that's outside the scope of my study, but I know there are other colleagues investigating this to try to understand where it comes from. Because of course, you can imagine from somebody, for example, from city management, it's important for them to know if most of the air pollution witnessed by their citizens is coming from somewhere else, or if it's coming from the city itself and there's something they can actually do about it, right? Instead of talking to Jakarta, they can first fix Bogor, something like that.
I have another follow-up. Sorry. Just wondering though, like, have you presented this data to the government agency or people who makes the policy regarding this? That's going to be interesting, right? Their response regarding this.
I have not. There are colleagues. The center that I worked for at IPB, they have contacts with the city and they work with governments in many cities in Indonesia. They're well connected. That's not my job. My hope is to put all these results together in a paper and make sure that the paper is open access so anybody can read it. And then hopefully it'll become a resource.
Okay, thank you so much. We'll take two more questions from the audience. Two more questions.
Thank you. I'm Hernani from Universitas Trisakti. Actually, I'm not really a question. It's kind of like comments to add, like Mr. I forgot, Mario. He mentioned about the focus of the government, actually the ambient air quality, not the indoor air quality, especially at home. It's kind of, it's a private area. But for the buildings that Ms. Marina did a study about the mall and the office, they actually have to follow the indoor air quality standards. It's under the Ministry of Health standards. But for the ambient air quality, it's under the Ministry of Environment. It's different area actually. And in my opinion, I like to discuss more about the indoor air quality because not many people concerned about this compared to outdoor ambient air quality. But as Ms. Nina said, like we spend like 90% indoors and or 60-70% in our own home. It's more complicated. I mean, compare because it's a different home, it's different habit, and the type of house also different situation. And that's my opinion. I kind of just add. And right now for Jakarta itself, they already prepare for having the worst dry seasons for the outside or outdoor ambient air quality. And my questions to Ms. Nina is actually about the transportation. You already did for a car and motorcycle, and the issue for most cities actually for the public transportation. We try to shift from the cars or motorcycle to the public transportation. I'm not sure how extensive the public transportation in Bogor, but for Jakarta, uh, you know, LRT, MRT, and Transjakarta busway is gonna try to be more suitable for people comfort to shift from the car to motorcycles. From my past research comparing to the three mode of transportation, public, motorcycle, and personal cars, it's similar for the cars and or a motorcycle sometimes higher only for the transportation is not compared to other activities. But at the time only Transjakarta busway. So it's almost the same or lower compared to the motorcycle. But the problem, like Transjakarta busway, they have a lot of the station. So when they open the door, the outdoor pollution inside. So I have, did you do the comparison with the public transportation in Bogor? Thank you.
Thank you so much for your comment and for your question. I completely agree with your statements. And I think, yeah, I'll just highlight and repeat what Hernani said about the fact that indoor air quality in our own homes is unregulated. So, which is, good and bad. Nobody can come into your own home and tell you what to do or not to do. That's the thing. But at the same time, it falls on us, right, to protect ourselves. And there's a great variety of homes, apartments, houses, small, big, completely open, completely sealed, air conditioned or not. That's all going to bring forth, a great deal of variability and complexity for sure. That's why many, many studies like this are needed. One is not going to tell you all the answers. And about transportation, yeah, I try to recruit students to ride. We have in Bogor a lot of, I think they're called angkot, the tiny little buses. I have a lot of them and the bigger buses as well. But we weren't able to collect data. So unfortunately, what I'm showing you is what we were able to do. But of course, that's also very important to understand the exposure during public transport.
Thank you so much. We have question from the Zoom. So is using air purifier help in order to reduce the personal exposure indoor for the PM 2.5 level?
Great question. Thank you. And thank you for whoever asked online. Yes, I am a proponent and I definitely recommend using a portable air filter in your home. Air purification methods vary greatly. Prices vary greatly. What you want is something that is big enough for the space you're trying to treat. So usually they have a recommendation. So you can't take a tiny air cleaner, like a tabletop one, put it here, and expect it to clean this whole big room. It's not going to work, right? So it has to have the right size and power. If you want it to clean your whole house, it probably won't work. So if you have different spaces in your home, you're probably going to need a bunch of different air cleaners in those spaces. My recommendation is to put one in the bedroom because we spend 1/3 of our lives in the bedroom, right? If you sleep 8 hours a day, that's 1/3 of your day. So 1/3 of your life. So put it in the bedroom and that's going to really help reduce your total exposure. If the kitchen is centrally located, so you know the air pollution, if you can smell the food all over the house, that means the air pollution from the food and the combustion, if you have gas, is all over the house. So put one in the kitchen. So you're treating the air pollutant as it's being emitted. So yes, I recommend air filtration. The other methods get a little more complicated. I won't get into the details, but air filtration is great.
Okay, thank you. Next question from Arzu. Hi, thank you for this insightful session. I want to ask a question following on Sir Mario and Miss Alicia's questions about the effects of precipitation and temperature on these PM2.5 particles. In the 9 months of your research in Bogor, I wonder if you notice any changes in PM monitoring that could be related with changes in climate or maybe sudden weather incidents like hurricane or large storms?
Oh boy, that's a complicated question. Yeah, thank you. The effects of precipitation and temperature, notice any changes? Yeah, thank you. So I haven't done this yet, but I saw at least one student from IPB trying to link the intensity of the rain with the PM 2.5 concentrations. And it's tricky, it's complicated because it depends on the size of the rain droplet. It depends on how long the rain lasted. Sometimes I think some of the results that I've seen throughout the literature is if the source isn't gone, then the rain, as soon as the rain is over, it just comes right back up. So there's not, the effect, there can be an effect. Rain can help clear the atmosphere of several air pollutants, depending on the droplet size, again, depending on how heavy the rain is. But as soon as it's over, if the industry and the traffic and whatever it is that generated in the first place, it's still going on, then it's just going to come right back up right after. There isn't a long-lasting effect.
Okay, thank you. Any more questions from the Zoom? No more? Okay. Oh, Sir Mario. Okay.
This is a very interesting topic, to be honest. I remember I was working in my molecular and cellular biology class about hydrographs. And at the time, the income level in this part was really high, and then I was explaining to students about that. But then in terms of policy making, for example, Indonesia is developing nations, and then at the same time, we have to think about the economy. The economy needs to run, industry needs to run. But then, of course, the health problems will also come because of part of the exercise. So when you are trying to compare the two of them, as someone who comes from this expertise or this field, what kind of recommendation in terms of policy? I don't know. Should we sacrifice one after the other, or what? What do you think? What's your own version of it? This is just ask you honest.
Yeah, this is a fantastic last question because it's broad. I love it. Thank you. I appreciate that. So as an environmental engineer, I am no expert in policy or public management of resources or international development. None of that is within my expertise. But the one thing that I would recommend as an environmental engineer is to put a price tag on everything, including human health. So when I was an undergraduate student 25 years ago in Brazil, I learned one number that I'll never forget, and that number was 9. For every dollar spent, for every Brazilian real at the time, spent in sanitation, you would save 9 in hospital bills. It's an investment, right? If you spend $1 in getting the water clean and the sewage treated, that's $9 that you save in hospital bills. So now let's think about the hospital bills and let's put another number to that. How does that translate to hours that the people had to stop working because they're sick, right? So once you start putting a price tag on that to the economy, then you can think about making choices, because it's not about sacrificing economical development for public health. Public health helps economical development, because then people are less sick, because then they last longer, then they're more focused. Air quality increases have shown that let me rephrase that. There are studies that showed that schools that were closer to highways in the United States, the students had a lower attention span, their grades were lower. So air quality needs to be considered into the math, the great math of the entire country, the entire nation developing, right? Because it even affects the way people think. It affects how long people live. It affects their cardiovascular health, so sick days in hospitals. So once you can really add all of those up and actually put a price on all of these things, then you can start having a conversation and make decisions. Yeah.
Thank you for the question. Sorry, I also have a follow-up question to that as well. Well, there's several sayings like in households, especially in lower income households, where they believe that the pollution is that we're already resistant. It's our everyday life. Is that resistancy actually real, or is it just a myth, or if you can comment on that?
I don't have a deep comment. I think it's a myth.
It's a myth.
I think
Okay.
it's a myth. You get used to it, but it doesn't mean that
You're resistant to it.
psychologically you're used to
Mhm.
it. Physiologically, I'm not sure.
Okay. Okay, so any more question from the Zoom or from the audience? I'll take one more question. Okay, so I'll give it 5 seconds. If within 5 seconds there's no more question, I will conclude the session for today. 5, 4, 3, 2, 1. Okay. Thank you so much.
Thank you, everyone.
Okay, so with that, I would like to thank everyone here and oh, there's another question. One more question. Oh, okay, sure. Oh, okay. Oh, someone wants to clarify on the question. For the home/inside sources of PM2.5 emissions are significant in this because of how the particles get trapped, right? So, but I wonder how the ratio of PM2.5 produced is like between industrial and home sources.
Yeah. Oh, yeah. Okay. I think I understand. So the question is about the source of the particles, really composition. Are some particles more dangerous than others? And the answer is yes. There are many studies on this. It gets very complicated. I can't go into too much detail as we're close to time. But if the particle is more crystalline, if the particle is made of metals as opposed to organic matter, it might be more toxic. Even within organic particles, the term organic is applied so broadly. There's something called PAHs, polycyclic aromatic hydrocarbons. And a lot of cooking emissions, car emissions, they can have those, and those are carcinogenic specifically. Those are very bad for your health. So some particles can be a lot more toxic than others. But then what also plays a role is within PM2.5, which is any particle less than 2.5 microns in size, there's a whole range of sizes within there. And then some of them will deposit preferentially in the upper airways. So then you swallow them, they're not as toxic. Some will go deeper into the respiratory system. Some sizes will preferentially deposit deep in the alveolar system. So then they're more toxic. So size within PM2.5 plays a role, but also the source. So the composition, what those particles are made of also affects toxicity. I think that answers the question. I'm not sure.
Okay. All Gucci? Okay.
Thank you.
All right. Thank you so much for that insightful seminar and discussion. And on behalf of i3L, I would like to express my gratitude to the AMINEF team and Dr. Vance for being here today. Before we conclude today's Power Talk, I'd like to invite our friends from AMINEF and the live attendees, everyone here today, to come to the floor for pictures and documentation. So please come, everyone, to the stage, to the floor. So you got so bad. This is my husband, Eric.
Hello.
She was my host at the Kati University.
Oh, Bapak itu.
Agak miring. Jangan lagi. Oke. 1, 2, ya. Satu, dua, tiga. To Dr. Vet and ask it. This one I'd like to give to Dr. Marina Vet. Thank you so much. Oh, that's funny too. Wait, I can't. Oh, maybe we'll take a picture. Thank you so much. Thank you. Thank you so much. Okay. Satu, dua. Ya. Satu, dua. Ya. Thank you so much. Okay, once again, our deepest gratitude to the team at Aminaf and Dr. Sit down, for that eye-opening power talk today. And with this, I would like to conclude today's session and also thank our attendees, both live and joining us in Zoom, for being here today. Please don't forget the attendance and evaluation form. Scan that barcode and fill it out accordingly. I'm Alicia Nazir, your moderator at i3L and representative, and I hereby conclude the session. Thank you and have a lovely day, everyone. Thank you so much.
Just a quick question. Is it like available for purchase and stuff like that? Like your.
Oh, yeah, this I bought online. I don't know